Thanks again, everyone, for joining us for today's Friday session, Data Science Seminar Series number 6. And we're joined today with Professor Uku, who's going to be taking today's session. Just so you all know, this session is being recorded. And like I said earlier, if you're able and you're in a great spot, we love to see the faces. You can feel free to turn on your camera. I know there'll be time for Q&A at the end. But I'm going to stop talking and I'm going to hand it over to Professor Uku, who's going to talk to you today about generative AI.
Thank you, Daniel. Hello, everyone. Can you hear me fine? Good? Okay. It's good to see some familiar faces. Hi, Steve. And welcome to people whom we are just meeting. Hopefully, it's going to be an informative 45 minutes and an hour. That's my main principle in these webinars. Let's learn together, let's think together, and then in the end, if it will be possible, we are going to be able to interact and brainstorm a little bit over the concepts that we discussed. So my name is Utku. Some of you already know that for the ones who we haven't met, let me quickly go over. I completed my graduate degrees in Northwestern University and the University of Illinois-Urbana-Champaign. And then since then, I do active research. We publish in multiple industrial areas of AI applications. I also work in the companies, and I have experience in healthcare, industry, finance, e-commerce, retail, technology, and airlines industry. I'm also teaching machine learning AI-driven courses at UIUC for the last 6 years. So before we jumped in, I remember while I was preparing this presentation, I remember 2018-19, Data is the New Oil, newspaper title. Do you remember it? Data is the New Oil. Where are we right now? Is it still an oil, do you think? Well, it became more sustainable right now. So if we think about that, what is it? Like how much data we are dealing with today in professional life, in private life, social life? We categorize them into 3 groups: structured, semi-structured, unstructured data. The reason why I'm telling you this, that's how the AI field evolved. Easiest way to operate and apply machine learning, data science, and analytics on structured data. When I have columns, we call them features, like the email, user logs, or risk score, and etc. And we are learning from the label column by showing thousands, sometimes millions of samples. And after showing this many samples, the algorithms are perfectly predicting, almost perfectly predicting the goal. If it's, for example, if this email is spam or not, if you show 100,000 examples, they will figure out afterwards. So that's machine learning AI 101. But one thing is, it operates on structured data. And what was the ratio? If we look today in the businesses, we only cover 10% structured data, whereas 80 and 90% semi-structured and unstructured data, meaning that our AI solutions were depending on the amount that we are consuming in here, which is basically limiting us. So then what did we do? We realized that every time with the OpenAI 2020 paper, when we do more training, longer training, we get better performance. When we increase the data size, we get better performance. These are the loss graphs. And when we use more parameters, longer neural network layers, we get better performance. So this is the fact. This is the call scaling laws for neural network models. If this is the fact, and if I know that 90% of the data is almost underutilized in my AI and applied data science or analytics workflows, how can I better utilize the untapped data? And then the field evolved in self-learning phase. I'm just going to keep it high level, and I will explain it with an analogy. Previously, we started learning from these supervised learning. There is a label, there are features, look at these features, learn from label. We call it supervised learning. And I use analogy that that's how we do teach a baby how to eat a slice of apple. We show them 1,000 or 100 or sometimes 50 samples how to eat a slice of a fruit, a slice of a peach, a slice of an apple, slice of an orange. After you show enough and the baby repeats, then they will learn how to eat a slice of pineapple. That's the supervised learning. But that was the first model we used AI in our workflows and lives. If you show enough samples, the algorithms will learn from it and do that job with a generalized manner. However, not all the tasks are in the world can be learned that way. For example, if you want to teach the baby how to walk, either you show 500 times, 1,000 times, 500,000 times, baby is not going to learn how to walk unless it will try and fail, unless it explore or exploit. There's going to be a lot of falling down and standing up and learning process. And those kind of tasks are utilizing the reinforcement learning algorithms, not the supervised learning algorithms, to be able to handle that task. It's the similar situation, like if you want to teach me how to play golf, even though you show me, give me the instructions 1,000 times, I'm not going to be able to swing it unless I spend some time on it, try and error. That's most of the automated car, autonomous vehicle technology are depending on this reinforcement learning. So we were very robust until 2020s in these two supervised and reinforcement learning. But as I mentioned that there are a lot of data that were untapped, meaning that I have enough data, but I don't have labels or not enough environment or agents to train them. So it was underutilized. How am I going to utilize that untapped data I'm not using? Is called self-supervised learning. But it started with the text, and I will stick to this baby analogy for the people who has not that much technical training on the AI field. Hopefully it's gonna be much more clear when I explain it that way. So when we talked about the untapped data, we said, what are we dealing with? What are the easiest way to ingest this data? I would look at online options. Well, if I can pile today, scrape all the data on the internet, this could be any articles, blogs on internet, academic publications, dialogues, social media networks, Stack Exchange, Wikipedia, GitHub, Stack Overflow. There are a lot of resources I can ingest, basically, and utilize. It's data in the end, and it's still an oil. And by using the self-supervised learning, can I learn something out of it? And I want to pause in here, and I want to ask you a question. If I ask you to learn everything on the web, how would we do it today? Any idea? If we want to ingest all the materials on the internet, how would we do it? Let me help. First, we structure, then we store, and we need time to ingest it. And as a person who's gonna be doing it is actually bringing a lot of difficulties because we are dealing with almost 6 billion pages of information on internet today. And if an average person spends 52 seconds for each page, it corresponds to 5 billion hours. And if you are sleeping 8 hours a day, working 5 days a week, it corresponds to 250,000 human years. And it is impossible to ingest everything on the web. However, with the hardware and computational technology, right now we can ingest and learn everything from those within a few months by generating foundation models. Foundation models are generative pre-trained transformers. GPT is one of the example probably you're very familiar with. But this computation capability, you see how NVIDIA and the other semiconductor technology are being evolved, is making this possible for us by just not imitating a person. Maybe there is a time that we can do something better than a human intelligence. So this is very interesting that I am capable of ingesting all the data, learn from it, then what am I going to do with that? How can I utilize it? And how can I actually channel this in my professional workflow? In this process, I want us to think about, again, a baby, a kid is growing up situation. So we are giving a lot of books to a kid. They're reading. And in the end, since they have read a lot, they highlighted important areas, they ingested, they understand the connections or associations among the words. Now it's time to speak. Before it's time to speak, baby is going to understand what is coming next when you leave a blank to be filled in a sentence. It's all started in our text messages and the Google search. If you just type the quick brown fox, then it completes, jumps over the lazy dog. It's not taking this from a database, but based on what we read, what the baby or the kid read among thousands of books, they know this sentence is highly cited, highly used together because they represent all the unique alphabetic letters and characters in our English language. Very common, and I can fill it up with using the associations among the words. Okay, baby read all these documents. Hypothetically, I'm trying to use an analogy. Now it's time to talk. How am I going to teach baby how to talk, where to talk, how to behave, what to do, what not to do? That's the second piece. So GPT and the transformers models are being trained on a large pile of data, understand the word associations, create that foundational model. Now I need to make it useful. Now is the second piece, what we call, let me just change the pointer. We call it fine-tuning. Now the foundation is set. Now I'm teaching the baby to carry out specific tasks. Hey, don't use this word when we go be guests in your friend's birthday party. Don't answer the questions like this. When I ask you a question, respond like this. When I give you this kind of summarization, A lot of tasks can be taught after you create that foundation model. And when you actually finish this fine-tuning stage, GPT become ChatGPT. So you're teaching baby new tasks after they learn the foundational language. Okay. How do we learn it? Fine-tuning. Hey, look at this. I want you to be able to capable of tell me what's a good text message or not. This is a good text message. This is a spam. This is a good text message. This is spam. Basically, we brought back that supervised learning onto instructions to give baby, since there's a foundation, to be able to capable of handling larger tasks and more mathematics, more reasoning. We can teach anything. We can teach sentiment analysis, we can teach question and answering, we can teach dialogue, we can teach summarization. This is how we raise our children and how their evolution is happening. Anyways, when we explain them how to solve a problem, we usually don't teach them to giving the right answer when I ask a mathematical question. What we do is, if you want to calculate something, divide the tasks, break it down, then the answer is 11 is much better than just telling the baby answer is 11. So I can learn better by using these techniques. We call them chain of thought reasoning. Now the baby is capable of doing calculations as well, because we were able to teach them after the foundation is set, reading all those books. And every time when I teach something new, this foundation model size is growing. We call them large language models. If you don't teach that many tasks on a child after reading all those books, I can talk about 8 billion parameters, only capable of question answering, language understanding. If you teach more tasks like translation, getting higher, more tasks, getting higher. It's around today a 1 trillion parameter size large language models. But what does it tell us when we actually hear these things? Oh, Llama just released their 100 billion parameter size Llama model. What does it mean to us? Let's make an analogy. It means, I'm gonna make the human brain and human intelligence analogy to be able to explain. Let's say GPT-3 was 100 billion parameter size. Those parameters was actually meaning that how many connections in my neural network architecture a model consists of. So GPT-3, 100 billion connections. Each connection is weight, that's a parameter. So parameter size 100 billion means in this architecture, I have 100 billion weights, meaning connections. But a typical human brain has neurons and the connections. And a typical human brain has 100 billion neurons itself. Think about the combinations of connections we can create. So GPT-3, 100 billion model, not even close to what a human brain is capable of. You can make the ratio, but it's very impressive that how much progress we have made by utilizing the self-supervised learning, by utilizing this untapped data, by utilizing the compute power we have with the advanced technology, computational resources, hardware. We are today around 1 trillion parameter models, GPT-4o, Gemini, Llama, and those foundation models that you're hearing or reading from the news. Okay, we'll talk about what's coming in next. I use this in my classes as well, and I want to ask and open the floor to you very quickly. What is the an anomaly here? Which number is abnormal? Can you write on chat if you don't mind? "26, 16, 56. There are different thoughts. I think the majority is 26. Why 26? Because we kind of remember our school times. Although I didn't give you any rules, you just thought that it's not divisible by 4, whereas all the other numbers are divisible by 4. But isn't it interesting how our brain goes and remembers what we were taught in elementary school or junior high, divisible by 3, 4, 5, 6, and within 1 or 2 seconds, we eliminated all the possible rules. The key is I didn't ask you which one is not divisible by 4. I asked you what is the anomaly. We generated the rules based on our previous learnings. That's the foundation. That's the strength of this generative AI technology. We remember, since we are ingesting a lot of oil, a lot of data, untapped data, now we remember the associations, we remember the rules, we remember the sequences, we remember the logic. Now we can answer this question without expecting a rule is specifically, explicitly indicated. And that's what we want to come at. We want to come to human brain level with this technology. Now, let's talk more professionally. What we can do with these models, we can do text generation. You are using your iMessages, phones, and the stuff, this auto-completing, right? It's remember what's going to come next. Text generation, Q&A, summarization. Right now, we can do with this foundation model, paraphrasing our emails. We can fix our code. We can generate images. We can generate voice. There are a lot of tasks this baby can still learn and build on top of that foundational knowledge and learning they have. Most of the focus was on text because text has a pattern. There is order, there is a sequence, and there is an association of the words. That's why most of the research on language AI. What is going to come next? If I mask one word, what it should be? Can I summarize this text? Can I check the grammar? Can I answer this question? Most of the evolution is around text, visual, speech, sensing, smelling, other senses that a human can capable of is still work in progress. A lot of work has been put in the image multimodal, but it's much more difficult than text because there is no pattern like what happens in Vegas. I can fill it up, stays in Vegas because I've seen it multiple times. But if you see a glass, it may not be that easy to predict what's next to that glass. It could be anything. There may not be enough pattern that we recognize. So there's a lot of ongoing work on the visual side as well. And that's why I just want to talk today how we are going to focus on the products of language AI, specifically within generative AI, and how we create scalable and valuable development around this technology. Great. First of all, think about your workplaces and how we can actually utilize these tasks this baby learn. Well, I can do customer-facing products, I can do employee-facing products, or I can do operational support products like call center. Can I create a chatbot that, for example, I'm a CEO of a hospital, then all the patients can get all the questions answered from one single place without needing you to call the insurance, call the hospital to book, don't know which specialty you're going to, don't know which physician that you want to go. All you need to do is, hey, I have a back pain. I'm available on Tuesday afternoon. I have Cigna insurance. I'm okay to make the video visits, and please make an appointment to me. That's all you need to type. It's all taken care of. It goes to internal scheduling. It predicts what specialty you should go for the back pain. It looks the schedule, who's available on that specialty in this Tuesday afternoon, who accepts video calls, and who's accepting that insurance, for example, can be done in one place. There are other ways that are, it's risky because we deal with hallucination. What if it responds badly? We'll talk about it. That's why customer-facing solutions are very difficult to productionize without getting enough experience beforehand. And that's why the companies are using the employee-facing applications frequently, first to reduce the risk, mitigate the risk, and then getting the maturity to be able to migrate it to the customer-facing applications. And how we can use it employee-facing application. But one caveat to do it is we saw this foundational models learn from the data, online publicly available data sources that created that pattern and association among the words from this publicly available data sources. Let's say you work in a company, a retail company, and these models do not know your internal data. So it may not be super helpful unless you introduce them how to operate, how to ingest this new internal data. The first thing the companies are doing right now is called retrieval augmented generation. What we do is we have this foundational model, but we have also internal company documents. I don't want to marry them up. I just ask a question and it goes to the internal documents, find the closest piece that may have answered, brings it back to our foundational model, and I generate the answer. I want to stop sharing and I want us to look at from baby perspective again. Think about a child read 100,000 books now, and those books are very popular books, no domain specific. And you are now asking baby to learn from 2 political science books, neoliberalism, all those advanced jargons they're using. Baby cannot understand that book and ingest to their mind right away. 2 books is not gonna be sufficient. And our internal company documents is usually that ratio because we trained on terabytes of data. You're talking me 20 megabytes of PDFs that you want the foundation model learn from it. It's not that marry up is not happening that easily. Instead of marrying them up, what we do is, what we tell this baby, look, I don't want you to understand every single detail in this political science book, but I want you to read it, highlight some important areas, don't have to digest. If I ask you a political science related question, go to that book and look at that highlighted area and return the answer. I don't need you to answer off the top of your head. Just go look at the highlighted and return it back. That's retrieval augmented generation. Probably you hear a lot, that's called RAG. We don't marry up internal documents with the foundation model knowledge. What would be the caveat on here? If you have not only 2-3 political science books, but you have 500 political science books. When you ask a question, baby can lose a lot of time. Where was that highlighted part? Where was the answer? It may create latency. Latency means you ask a question, model doesn't return the answer on time because it spends so much time looking for the right answer from those. At that time, that's the time for you to think about, should I marry them up? Instead of searching the answer, can I ingest that political science knowledge into the brain of the baby? And how do we do it? We just start with the beginner level, medium level, advanced level, learn, understand. After reading almost 500 books, now baby have an inbuilt political science knowledge. If you ask a question, they can answer off the top of their head. So in the companies, what we need to do is, where are we? How much time we are losing when we apply these RAG solutions? At the same time, let me share my screen again real quick. When is the right time to do the fine-tuning? Fine-tuning is the process ingesting that information into the baby's brain instead of going after and looking at the highlighted parts. So we are here, RAG. But if the document size gets too much, we may need to start thinking about how to marry up that information into the baby's knowledge. So what is that number? Is one thing a leaders in this field and the product managers has to plan in advance. 20 gigabytes of data, 40 gigabytes of data, get the latency scores, how much time I'm spending for 10 gigabytes of documents to find an answer, and then I can explore and understand the scale, and I can understand when would be the right time for me to actually think the second option, which is the fine-tuning and the other advanced methodologies. I have my personal topology where this field is going. And I will look at from a product company perspective as well. Think about a GPT solution, enterprise GPT that we are utilizing either in personal life or in companies. Many of the institutions are adopting enterprise OpenAI GPT, let's say, similar to ChatGPT. Who is the target audience? General user. Anyone can use them. As long as you can type a query, ask a question, here is the answer. Next, I think the managers and the leaders in the companies are capable of using the RAG with the internal documents. Because right now, I'm in a retail company, I'm asking a question, what is the most successful sales representative of the last year? Can you look at this monthly report and tell me what's the name? ChatGPT will not know it because it doesn't have internal knowledge. So I look at the highlighted areas, I retrieve that information and help the managers and leaders with the RAG solution that we have, that I described. Not marrying up, keeping them up separate. Whenever a question is asked, it's going there, finding the highlighted part and returning the answer. I'm asking who is the most successful sales representative. It goes to the sales reports, look at the numbers, gets the name, Steve, and tells the answer. So managers and leaders can use it. The next level, I think we are here right now. The next level is gonna be the analysts. Today's data analysts, business analysts, financial analysts, they write SQL queries to be able to get information from structured data warehouses, right? Can you tell me the average sales amount in this region? Select star, blah, blah, blah. And only data analysts can do it. If you don't know SQL, you may not be able to get this information and retrieve this information. And it works very well with the descriptive analytics purposes. And now we are trying to solve it. It's still not solved. I'm in touch with the AWS Innovation Lab team members, the West Coast researchers. It's very interesting because when you ask a question, for example, let's say you are in airlines industry, what was the highest ticket price that we charged to a customers year to date? That question goes into data warehouse, look at the prices starting from January 1st up to date and retrieve that answer. But if you also ask, what was the highest price that we charged to a customer and what happened that day? What happened that day needs to look and scan all the news, blogs, all the other unstructured data repositories, and need to tie unstructured data and structured data together to answer that question. It is the next big thing that we are expecting, thinking the data engineering, data modeling differently than how we were doing today, because right now structured data is their relational databases, warehouses, all we store them separately. Unstructured data in S3 bucket in the cloud repository separately. There is no connection between them. So that's the next gen revolution that I am projecting, which we call it Gen BI, Generative Business Intelligence. And after that, can we target audience as data scientists in our company? Predictive analytics. For example, anomaly detection problem that I show, this one. Can we solve these problems? Think about all these values are numbers and categories, and we use mathematical models to learn. Can we use large language models or generative AI to learn from these numbers or this kind of structured data and make a regression output? There is very interesting research going on that. What the people are experimenting right now, instead of working with numbers, can we create stories for each row? Instead of representing them with the numbers, can we actually represent them a paragraph? Hey, in this date, this much amount spent by Jack with the ID, located in Illinois, used the social media channel, and didn't commit fraud. Instead of representing in a tabular form, I can represent it in a paragraph and label, and the foundation model can learn from these stories and answer, maybe predicting the fraud instead of training an XGBoost or the random forest model that you most have familiarity for. So the field is shaping into that interesting direction. So what we are going to be doing as the product, as the leaders of this field in terms of the product perspective. First of all, there is an interest on the small language model because of the computational cost and other bottlenecks that we are dealing with the large language models. Enterprise GPT, OpenAI, $3 million base price. And every time you send a request, you're getting charged accordingly. Open source models have a lot of capabilities, but now you have the hardware cost for them. How many GPUs you will need to run a Llama model, larger Llama model, to get your job done. That's why there is an interest in small language models. Do we really need that big of large language models for some of the tasks? So going back to this, do I really need to have a model which is capable of doing all these things? Or for some tasks, I may be okay with this capability because I want to teach new tasks for these models. especially because of the internal product needs. When you try to teach a new task, new skill to these models, where should we go and how should we strategize? And another analogy, I like to use it, and I'm learning a lot about the young newborn babies and toddlers nowadays. It is not easy to teach an adult how to speak Turkish language. But if you spend the same time on a kid, like 3, 4 years old, they learn much more quicker than an adult. Can you tell me why the babies can learn a new language, or the kids can learn a new language much faster than adults? It's basically the same discussion that I was trying to bring. Because if the brain is too evolved, it is very difficult to marry that up, that new information, if there are already a lot of tasks over there. That's the brain memory capacity, versus if the brain is fresh and has capacity, it gets the new tasks much faster to be learned. As the product people, we have to keep this in mind. When we want to teach a new skill to our generative AI tool, not always the biggest or bigger models are first place to go. Because of the cost, we will discuss, but more about the increased capability of the small language models over large language models. One area to keep in mind: a small language model can contain 7 billion, a large language model can contain almost 2 trillion parameters. Okay, let's talk about the options. Let's say we want to create a good information retrieval system to our customers and serve it as a product. First of all, you need to choose what's your foundation model. Is it a small language model, large language model? Do you want to use the Llama, or do you want to use GPT-4 or Gemini? Where to go, how to decide to backend bus driver? First of all, we need to make this separation: open source and the proprietary models. Do we know the difference of those two? Open source models, how they were trained, which data are used, are publicly available and transparent. We can replicate it, like say Facebook Meta Llama model. On the other hand, GPT-4 is closed book. The code never shared by OpenAI. They keep it as a proprietary model, similar to AWS Cloud, Anthropic Cloud. We pay per usage to those proprietary models. On the other hand, for the open source, it's free, but we have to pay for the hardware. So let's think about the scalability part. The benefit of enterprise proprietary models, which we bring to our companies, make a Azure OpenAI deal, bring the GPT, let our people use it. We don't have to worry about the hardware cost, but what we worry about, requests, how much query that I send, that's how I'm being charged. How much longer that I write on those queries, that's the amount that I'm paying without dealing with our hardware costs. If I opt in not to use that proprietary models, but I want to use open source Llama model, now I have to pay for GPU cost. And one GPU is $8, $6, depending on NVIDIA pricing and other companies. But it's not only the cost. Proprietary models bring enterprise-grade support, high performance, enhanced security features. There are a lot of perks that we cannot risk in the companies to go in the open source part, because open source model doesn't come with those additional important dimensions that we can easily productionize and use it in our workplace. That's why NVIDIA came up with a solution. It's called NVIDIA NIM. What they do is, they said, You don't have to pay for the proprietary models to OpenAI or Azure or Amazon. We'll let you use the open source models because we requantize, retrain them. It comes with the enterprise support. It comes with enhanced security. All you need to pay for are GPUs because these models are only working on our own NVIDIA GPUs. That's the third option, just to keep you in mind. There are still utilization open source in a safely scalable manner with the under the NVIDIA umbrella with their new framework called NIM, NVIDIA NeMo Microservices. Okay. And it also does multi-models. And I want to give you a cost experimentation analysis. Which one is more beneficial when I design my product? How am I going to estimate the cost? Proprietary models, I pay per request. Open source models, I pay per GPU hours. My personal experiment, if I get less than 400,000 requests per month, proprietary models are much more cost effective because you pay for unutilized GPU money in the open source models. But if the usage, traffic volume, throughput goes up to 10x to 4 million, then scalability wise, moving to the open source models, using the NVIDIA GPUs are more cost effective than paying for proprietary models. Let me repeat again. If you don't have that much traffic on your generative AI products, it's more cost effective to use proprietary models where the business model is pay per request. How many queries you type, you get charged accordingly. If that traffic and throughput is not that high, commercial or proprietary models like the OpenAI, Azure, or AWS Bedrock seems to be a good way to go. Everybody's experiment could be different. But for example, when I tapped on over 2 million requests per month, requests means each query that you're sending. What's the capital of France? That's a query, that's a request. And every time OpenAI use some hardware power computation to send back you the answer, that's the cost of one request, 3 cents, for example. Then if you get the throughput and volume high enough, then that may be the time for the product leaders to think about changing the strategy towards more secure, safe, and less costly options such as NVIDIA NIM and the open source models. Okay. After we our production, we estimated the projected the value and the cost. Now, how am I going to measure the value? This is an ongoing conversation, and it opens up a lot of interaction with different business stakeholders. But this is how usually people are thinking of that. When you actually come up with an employee-facing Gen AI product, what we need to keep in mind to measure the KPI. First of all, you need to be in good coordination with the analytics data science teams, business units, finance team for this cost estimates, legal team for the compliance issues, responsible AI teams for the risks that we are not doing anything wrong, and the other digital technology partners. First of all, coordination required. Second, how am I going to measure improved productivity, engagement, resolution, satisfaction, user throughput, trends, goal achievements? There are multiple metrics. The interesting part of that, when you deal with the productivity, we have to actually start thinking about how we are going to log the user activities to be able to interpret them later on to quantify the productivity to some extent. So what I'm trying to say, this is one sample dashboard that I can utilize. We deployed a chatbot for internal employee usage. All I need to do is I need to keep track of before deploying, I need to keep track of the general overview dashboard. For example, total number of requests, recent in the last 24 hours, total user count, tracking daily metrics, average response, average request, text length, and more importantly, the feedback, thumbs up, thumbs down, how positive the responses are satisfying the user. The biggest difference of Gen AI than regular machine learning and AI methods, let's say I'm asking GPT, I want to go to Italy. Can you tell me 10 places to visit in my trip? And the GPT is going to say, you can go to Rome, visit the Colosseum or the Lake Como, and get a great wine in this area. But I want to go more south to Amalfi Coast and enjoy the sun and beach. Its answer is not incorrect, but what we call it, it's not preferred. So when I ask again, I'm going to go to France around the same time, it has to understand, oh, this guy asked me before Italy, Amalfi Coast, he doesn't like to go see crowded cities. I should tune my response accordingly based on the user. So how am I going to tune this? I need to capture every interaction of the user by logging their user ID, their responses, their questions, categories, why they're using it, what kind of questions they're asking. They're rewording it, they're using it for summarization, they're using for creating some plans, they're using for the code fixing. I need to learn over the time. That is a very important thing as the product leaders we need to keep in mind before we release the beta version of our product. This all needs to be set beforehand to capture all the interactions of the log from the user, then process it. What kind of questions they are asking, what are the topics, are they satisfied, thumbs up, thumbs down, what is the average length of the queries they're typing, what is the average length of responses we are generating, speeds, utilization, etc. is going to help us to learn over the time and customize it better to make it the perfect product after beta release. Finally, monitoring and observability is very important on this. Metrics definition, optimizing performance, reducing the cost, all these things are linked together. But again, it's only doable if we do a good job on data capturing before we release the product, get all the data capturing, analyze, process, and then create the strategy, which it will help. Some of the ideas, guardrails, this data capture is help us for the audit reasons. Building the Gen AI literacy is going to be important. Reusable patterns, feedback driven. We are going to use this for data augmentation. We are going to use this for model evaluations. And there are going to be a lot of spectrum enhancement from the utilization that we can get from these large language models, and especially monitoring is also very important. When we say the monitoring in the traditional machine learning and the supervised learning, as I said before, it's easy, accuracy, it's black or white, it's green or red, right? It's precision recall, we can easily quantify it. But as I said in the Italy example, it may not be quantifiable as easy as before. Sorry, I talked too long, and let's open up for the questions a little bit and make it interactive if everyone, if anyone has anything to ask.
No, thank you, Professor, and feel free. I know we got a few moments here. If there's any brave souls out there that want to unmute and raise your hand, you can ask a question, or if you want, you can put it in the chat. Yeah, feel free to use the raise your hand feature if you want to ask a quick question. We got a few moments.
Sean is saying that thank you for talking so long. It was great. I don't know if it's a good thing. I usually can't talk days and nights about this because this is the passion.
Yeah, it looks like Kamal has a question, so take it away.
Hi, as a person who just rolled out a beta of a product today, I'm really excited about the options you have talked about, collecting the interaction data, the insights from the users and everything. But it's a lot of data, and it's a lot of privacy invasion. In my context, that's a really important problem. How do you think of the diminishing returns on collecting all this data? And how do you weigh, like, if the model gets smarter, better, more helpful, or not? And when do you stop? Because there is no end to this, right?
Correct. That's a great point. So data capture dimensions, I call it. Let's say we collect data from 20 different dimensions, like the logs, response, traffic, and everything. That's to understand the initial impact, like how the people are interacting, how many users we are adopting every week, how many questions they are asking every day, or is there any utilization that I can reflect on the productivity and the value proposition? That's one piece. After that, second piece is more important, that how can I actually tailor and more customize the output of these interaction to the specific person, because we use personal identification information, either Azure ID or the UChicago ID to log in. Now it's person. We know who's interacting, what kind of questions, that the privacy issues coming there. Basically, it is a tree-based topic classification. It starts from 5 major usage categories. It could be content creation, it could be email rewriting, it could be code completion. Then over the time, it converges to top 5, 6 categories. Then you don't need to collect anything else. So out of those converged categories, how we can actually improve the responses based on the negative feedbacks that we learn from. For example, when we first made our release, positive feedback versus negative feedback was 70% positive, 30% negative. What was the reason for the thumbs down? One sentence everyone was writing. Then we get those feedback to put in the model as an instruction to serve better to needs. Then that 70-30 go to 90-10. After that point, it is opening up the door, small language model, large language model. Do we want to use GPT for all, or how we can actually teach this model from these expectations at the user level to provide more refined answers? One solution is that keep the chat history, and every time user logs in, when a session is open, during the session on, it can remember and customize. I don't know the right answer to that question, where it can go, but the personalization is the key. The biggest problem in that, Kemal, is how we can open up internal data into that system, and how we can orchestrate the access of each user to different knowledge bases without violating any security issue is the ongoing task most of the researchers are focusing on.
Thank you.
Amazing. Yeah.
Jake, I think we had time for maybe one or two more. I think Jacob or Jeffrey had a question.
Oh, I'm sorry. I didn't know we had more time. Yeah. Hey, Uku, how are you?
Good. How are you?
I'm great. you mentioned sort of a scenario where people were essentially using language to query large data sets of like company level data. As somebody who like spent a lot of time at a large corporation, I can tell you that there's incredible value in that, right? If you have a manager that could just be like, what's the trends, and if you could establish parameters based on, you know, a really short 10-15 minute conversation of like, what are the things that would interest you in this data, and they could communicate that in words, and then, you know, essentially query the SAP database to, you know, execute and output a series of data. I'm guessing this is something people are actively working on, but I just wanted to get your thoughts on, you know, how easy that is for enterprises to build internally, or is this something that needs to be built by the SAPs of the world and just rolled into their product?
That's an amazing question. It's a startup idea, by the way. It's very powerful. It's not resolved and solved yet, but the key problem on there, again, think about a human intelligence perspective. Companies are so used to work in silos of data stores. Like data lakes are in here, data warehouses in here, S3 buckets are there, and other things. Those are all decentralized. And there is no connection among those. So what we are actually, my team in my startup and the other developers and researchers, what we are working on right now is how we can actually point each silo to the relevant piece in the other silo, then combine them, then return the answer. It's an ongoing effort, but it's a very huge, high potential effort, and it's doable. It's just requires redefining the data model, how we are going to store, manage, and govern our data. We basically going back to early 2000s when the initial business intelligence game started, how big data started, how do we handle these? Right now, revisit needs to be able to fully utilize. And when you think about human intelligence, when Kemal asked me a question, my brain went to my experimentation, my brain went to my research results, my brain went to ongoing papers that I read to be able to answer his question, right? Like multiple places come in. And my brain couldn't successfully combine all these three and give a final answer. That's very difficult for a human. Same in this big data world. Like if I ask a question about internal data, it's gonna go to data lakes, it's gonna go to data ocean, it's gonna go data warehouse, it's gonna go to confidential contracts, look at the numbers, pricings, all those deals data to combine it is the same difficulty that we are having as a human, but it's doable. It's not scientific problem right now with the current science and technology that how we are orchestrating foundational models could be done, but it's more of an engineering problem, how we are going to define and create the designs and ER models is very attractive to me, actually. Hopefully next year, most of my first 6 months in the next year, we're going to be focusing on that area. And actually, it's tied to this, right? When you do this, it is basically finishing up the third milestone that I wanted to, oops, sorry, where is it? I wanted to show. It is the completion of this third one, Gen BI. How am I gonna, when I finish this, then I can redefine the AI and predictive analytics and data scientist tasks as well. But this is the upcoming effort for everyone is focusing on. There are new techniques called table augmented generation, for example. A lot of interesting approaches trying to cater for this. And one thing is not internal, also the agentic workflows. It has to look at the search, internet, compare what you have in company versus outside. All together, think about an ecosystem can operate harmonically and in a synergy to be able to respond to that question.
Exciting stuff.
Yep.
And then I know we are over time, but he's been having his hand raised for a while. Uku, do you have time for one more?
Yeah, I have time.
Okay, so this will be the last one. Jeffrey, feel free to, take it away.
Awesome. Thank you, Ukuzu. My question is about that 400,000 requests per month benchmark you laid out. It's basically like once you get over 400,000 requests a month, that's usually when it becomes more cost effective to host your own open source model. I'm guessing that that's kind of like a rule of thumb to keep in mind, because of course your hosting costs are going to depend on what model you're hosting, what the infrastructure requirements are. Is that just more something to keep in mind as you're scaling up, or is it something where it's even more abstract than that, and it's really like once you if you're expecting to get over 400,000 requests a month, you really just got to dig in and like do the math on the individual model you're running?
Yeah, that's a perfect question. That number has more load in it. For example, the right way to calculate is look at in different environment levels: dev environment, stage, and product environment. There are a lot of people are utilizing and making this request in the dev environment before they finalize a product and serve it live. So it incorporates that one as well. My 400,000 for only the products who are live and productionized already. It's basically specifically enterprise GPT requests, and also the Bedrock Cloud Anthropic model development and internal RAG use case usage requests combined. Anthropic Cloud has a cost like 3.2 cents per request. Azure OpenAI is different. So it's the average of those two property models, and that's the aggregated number of requests that we collect from multiple use cases that we released.
Awesome. Thank you.
All right.
Great question.
Yeah, and thank you everyone for joining us. Good start to the weekend, and thank you, Professor, for taking the time. If you have questions, some of the names here look familiar. I know we've been in touch. I know some are actually current students, so don't hesitate to reach out. But go have a good start to the start to your Friday. Good start to the weekend, and thank you again. And we'll all be in touch soon. All right, thanks everyone.
Have a good weekend.